Hi guys, welcome to Algebra 1, Lesson 53. We're talking about rectangular coordinates today. So we're talking about graphing, which I think is really fun. It just might be a little long, the explanation. But before we get there, let's talk a little bit about polynomials because they are an important base for your graphing. So first of all, we learned that the degree of a polynomial is the sum of all of the exponents of that term. So for example, 2x cubed is a third degree polynomial because your exponent is 3. X is a first degree polynomial because you just have the exponent of 1, so first degree. XYZ is a third degree polynomial because you add up 1 plus 1 is 2 plus 1 more is 3, so it's a third degree polynomial. Now for these are all monomials. These are polynomials, trinomial, binomial, monomial, because you're adding them together. So the degree of a polynomial like this, where you have multiple terms, the degree of a polynomial is the degree of the highest term. So here, this term has a degree of 3, x and y has a degree of 2, and n has a degree of 1. So it's a third degree polynomial because the highest degree is 3. Here, x has a degree of 1 and 4y has a degree of 1. So the degree is 1. It's a first degree polynomial because that's the highest exponent you have. This is a first degree polynomial as well because you just have your exponent 1. Now if you take two polynomials and you connect them with an equal sign, you have a polynomial equation. And just like with a polynomial, the highest degree of a polynomial equation is the highest exponent of any of the terms. So here I have x4 minus 3x squared plus 2 equals 0. Well, this has a degree of 0, this has a degree of 0, this has a degree of 2, and this has a degree of 4. So the highest one is 4, so our degree is 4. Okay, xyz plus y plus 4, well there's a degree of 0 here, 1 here, and 3 here. So this is a third degree polynomial. Y equals 2x plus 4. Well, this has a degree of 1, degree of 1, degree of 0. So it's a first degree polynomial. This type of polynomial is what we use often when we are graphing. I have two variables, and it's my equation is in the first degree. So when I have two variables, there are an infinite number of possibilities that could make this particular equation true. So let's say, for example, I said that x is equal to 2. I would put y equals 2 times 2 plus 4. Then I multiply, 2 times 2 is 4, plus 4 is 8, so y equals 8. But what if I changed and I said I want x to be negative 5 this time? Well, y times or equals 2 times negative 5 plus 4. 2 times negative 5 is a negative 10 plus 4. Negative 10 plus 4 is the same as negative 6. So in this case, y equals negative 6. So it changes based on x. Because of this, we know that we can mathematically assign x any real number and use the equation then to find the value of y. Or we could switch it and we could assign a number to y to find the value of x. So when we assign a value to the variable x, we call this our independent variable because we get to choose what x is. But we call y the dependent variable because it depends on whatever value we assign to x. Y will change. All right, you could do it the other way around, like I said, where you assign a value for y, but in math, in algebra, we typically do not. So just to avoid any confusion, we are going to always assign the value to x. So x will be our independent variable, the one that we get to choose, and y will be the dependent variable. Okay? We could write this as a pair. So we could write our x and our y values as a pair. When you do this, you write it in parentheses. X is always first, and then Y. Think of it as being alphabetical order. X, Y. So when we write our variables, it's X, Y, like that. So this one will be 2, 8. And this one, my X is -5, and my Y is -6. Okay? We call this, there's a special name for this, and this is an ordered pair. It's your set of X and Y's that would make a particular equation true. It's your ordered pair. X is always first, then Y. So that's very, very important to remember. Now, we've learned before that you could graph something like this, Y equals 8, X equals 2. You can graph that on a number line, so a line that goes across. But when you have those two different variables, Y and X, you can't just do it on one line going across. That's why we have this graph where you have a number line that goes across and a number line that goes up and down. These lines here we call the axis, and they represent the number 0. So this right here is your x-axis, and it is all the numbers going across. This line is your y-axis, so it's all the numbers going up and down. There's also names for each square of my graph. We call this graph a Cartesian plane. A Cartesian plane. That's just a special name for a graph. We'll just call it a graph, but you can call it a Cartesian plane. Now, by the way, you are going to need to get a graphing notebook, okay? Graph paper, notebook. So until you do, you can just draw the graphs when you are required to make a graph. You can draw it in your notebook, but you do need to go and get a graphing notebook. It can be a tiny one, it doesn't need to be big, you know, little notebook. You can find them in Eldon's or Plaza Mar. Get a graphing notebook, okay? So this square, we call it the first quadrant, because it's the first square, quad, square, first quadrant. This one is the second quadrant, then we have the third quadrant, then we have the fourth quadrant, okay? In order to graph something, on this Cartesian plane, it was something that was come up with by a French philosopher and mathematician whose name was René Descartes. We just graph our ordered pair on their particular axis, okay? So for example, hold on one second. Okay, I want to go ahead and read through with you on page 196. I want to read these two paragraphs at the top of the page. So the first full paragraph, when it says when we use a single number line, right there, and then the one right below it. Okay, so let's read those through together because it has some important information. When we use a single number line to graph a solution to an equation in one variable, such as x equals 2, and they show you that number line below, we call the mark we make on the number line the graph of the point. And conversely, we call the number the coordinate of the point on the line designated by the graph. The point is defined to be without size, and thus the graph is not the point, but denotes the location of the point. Okay, so basically what that is saying is when you show a number on a number line with a point, we say that you're graphing the point. And that point, or the number, is the coordinate of the point. So the coordinate is where it's located. So the number is the coordinate of the point. Let's look at where it says since a rectangular. So since a rectangular coordinate system, that's the name for the graph, has two number lines, it is necessary to associate with every point on a rectangular coordinate system two numbers or coordinates. Okay, we have the two axes, so we need two numbers, two coordinates. These numbers designate the location of the point. The following figures show the graphs of 4 points, so we're going to do that together in a minute. Written by each point is the ordered pair of values of x and y that we associate with the point. These numbers are the x and y coordinates of the point. The number written first is always the x coordinate, and the number written second is always the y coordinate, okay? The number denotes, so that it shows the measure of the distance of the point to the right or left of the vertical axis for x. Okay, so let me back up to x. Sorry, you might be getting confused. Let me back up to x. So x is always the first number. It shows the distance right or left of this vertical axis. So right would be positive numbers, left would be negative numbers. Okay, so right or left. The number written second is always the y coordinate of the point and is called the ordinate of the point. You don't have to worry about that name. The number denotes the measure of the distance of the point above positive numbers or below negative numbers on the horizontal axis. Okay, so in your example, 53.1, it says graph the points whose coordinates are given. So A says 3, 3. Okay, so that means x is 3 and y is 3. So we always start with x. Always start with your first number, which always is the number for x. And remember, that's the one that goes across. It's a positive 3, so that means I count. So here is 0. Remember, my axis means 0. So that means next to it is 1, 2, 3. So that's x over, but I'm not done. I also have y. My y is positive 3, so that means I count 3 up now. 1, 2, 3. So right there is where my point goes, okay? And on your example in the book, it has more written there. I'm not gonna write more on this graph so that it keeps it nice and clean for you to see it a little better. But this is the plot of point 3, 3. So that's what we say when we put our points on our graph, we are plotting it. Okay, let's do negative 4, 0. So negative 4 is the x, so that means I go to the left. 1, remember, this is 0, this is not 1, so don't count the middle line as 1, it's 0. So we start with 1 on the one next to it. So negative 1, negative 2, negative 3, negative 4. Then it says 0, so that means I don't go anywhere on my y-axis. I stay right there on this black line. Negative 4, 0. Okay, let's try another one. 0, negative 3. So 0 is my y, so that means I don't move anywhere on the y-axis, is my x. I don't move anywhere on my x-axis. I don't go this way, I don't go this way. It's 0. Negative 3, okay, that means I go down. Negative 1, negative 2, negative 3. So there's the graph of my point. And our last one is 4, negative 2. So I start up here with my x-axis. 1, 2, 3, 4. Negative 2, so negative 1, negative 2. And there's the graph of my point. Okay, super easy, right? Okay, so for your practice, this is graph the points whose coordinates are negative 6, negative 7, and 4, negative 5. All right, like I said, if you don't already have graph paper, just draw the x and y axis in your notebook and use your ruler to make some straight lines and graph it that way. Okay, if you have not yet paused your video, make sure you pause it before you keep going. All right, letter A is negative 6, negative 7. So negative 6 is our x. So we count over negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. Then we count down, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. Whoop, negative 7 is way at the bottom of my particular graph. Okay, so that's where it would be. All right, and then B is 4, negative 5. So x is 4, so I count over 1, 2, 3, 4. Y is negative 5, so I count down negative 5. Negative 1, negative 2, negative 3, negative 4, negative 5. And I plot my points, okay? So that's all that you have to do. Let me know if you have any questions, and I will see you in the next lesson. Bye.